Today's new material, the evil kitchen box of doom, or why can't you get cancer from a microwave? But there's merit in not standing directly in front of one anyway. First and foremost, let's review what we know about the electromagnetic spectrum. We found out yesterday that radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays are all the same type of wave. They only have different properties because of their different wavelengths. Microwaves are the second to longest that we have, less than infrared heat waves and a lot less than visible light. When we talk about getting cancer, we're talking about a very specific case of destructiveness. And as we saw from our formulas, destructiveness is measured in joules of energy. If you get 100,000 joules of kinetic energy going whap bang in front of you, it's going to knock you off your feet, whether it's an ocean wave, an earthquake wave, or a wave of football fans whose team has just won the Super Bowl. Take a look at the formula for energy. Frequency is the problem here. High frequency makes for high energy. Let's say you lost a bet. You bet on the wrong team for the Super Bowl. Now you must perform an embarrassing sports-related forfeiture in front of the whole school at Tefillah. Or, worse, you've lost a bet with that annoying friend who says he now gets to punch you 5 times, as hard as he can. You can't duck, you can't wear football armor, and you can't stand on the other side of a glass window telling him, okay, I'm ready now, throw your punch. You have to stand there and take it. How is it that you can take those 5 punches of sports-related forfeiture and still be perfectly fine if you're not allowed to duck, dodge, or weasel out of it? Think about it. Call it out. Ask for the Sassy Pants opinion of anybody else in the room. Press play when you think you've got an idea. Ready? Well, the best idea I've heard that doesn't involve ducking or wheezing or weaseling out of it or putting something in between you and your obnoxious friend is saying, all right, 5 punches, 1 punch every 20 years. 1 now, 1 when we're 30, 1 when we're 50, 1 when we're 70, and if you're still here when I'm 106, that's when I'll take the 5th punch. Something tells me those last 2 are not going to hurt very much, especially the one when you're both 106 and pushing up daisies. More importantly, if you get punched once every 20 years or so, that's a pretty good record for the defender of truth, justice, and the white Anglo-Saxon Protestant American way. The real problem would be if instead of taking 5 punches in 100 years, you'd be taking 5 punches in 5 seconds. You know, that you're going to need some reconstructive bone surgery for. There's no getting out of that. The issue isn't that you got punched 5 times. It's that you got punched 5 times so quickly that your body didn't have time to recover and rebuild itself from the first one before the second 4 came crashing along. Frequency is the problem with electromagnetic radiation. All these electromagnetic waves, to a certain extent, can pass through your body, including visible light. Not to your eyes, but to the eyes of an unborn fetus, the world is bathed in a pleasant red glow from the inside of its mother's tummy. And if you don't believe me, I've got a friend in Israel whose ultrasound pictures show, and I've seen many, many more, especially in 3D photography, where they have incredibly light lights, of this cute little unborn baby photographed going like this, shielding its eyes from the bright light. Tova in Israel was particularly known for swimming away from the bright light so that the doctor couldn't get a good picture of anything other than her tuchus, and they were worried she was going to have birth defects or something because they couldn't see. You are transparent to everything here, some more than others. Electromagnetic waves carry quite a lot of energy, and when that energy hits you, it has the potential to knock codons off your DNA. DNA is very fragile. All those linkages, all those CAGTs, they're very, very easy to mess up. And the most easily broken and disrupted codon is the stop codon. There are more ways of saying stop in DNA than any other instruction, and you change one little molecule on one edge, and it doesn't say stop anymore. So what do the cells do when they've been damaged? They don't stop. They grow out of control, and that is what is a tumor. Tumors are cells that keep growing and growing and growing and growing and growing and have lost the ability to stop. If more DNA damage has been done than just the stop codon being broken, then whole chunks of the instructions have been taken away, and the cell is making the wrong protein, making skin in the middle of your liver or whatever it is, and it's growing and growing and growing the wrong thing in the wrong time, and it won't stop. That's cancer. So, what kind of high-frequency radiation gives you cancer? Look for the high frequencies that are going to be a problem in the energy formula. Pause, shout out your answers, and press play when you're ready to check. Ready? Let's see. Ultraviolet is high frequency, X-rays is high frequency, gamma rays is the highest frequency of all. We know all these waves on sight that they are toxic. Why are they toxic? Because they've got such a high frequency. These are frequencies in the gigahertz. These are frequencies in the terahertz. These are frequencies in the, we're running out of metric prefixes for more than 10 to the 15th hertz. You're being punched trillions and quadrillions of times every second by these high frequency waves. I don't doubt that they will knock not only the stop codons off your DNA, but several other important instructions for living, breathing, standing up, and being you. Ordinarily, your body can deal with this. There's a certain amount of background radiation that we grew up with. We call it background radiation. We're adapted to it. 4.5 Roentgens per year is perfectly safe, because if a cell goes offline and starts making eyeball in the middle of your stomach or whatever it is, then the handy-dandy white blood cells come by, says, whoa, you're out of control, you're out of line, buddy. Take that cell down, eat it for breakfast, and it can do no more harm. But if you've got more cancer cells in your body than you have white blood cells to police them, then the cancer is really going to take hold. Wait a minute. We said this had to do with frequency. And we said microwaves aren't high frequency. Where are microwaves on this? Microwaves are second to the lowest. Visible light has a higher frequency than microwaves. I ask you, can you get cancer from your Shabbat candles? They glow, they're emitting visible light all over the place. If the answer is no, you can't get cancer from a light bulb, you can't get cancer from a rainbow, and you can't get cancer from your Shabbat candles, then alachat kama v'kama, you can't get cancer from a microwave. A microwave is even safer than visible light. It has hundreds, it has thousands of times lower frequency than visible light that is perfectly safe. So, what's the problem? If we've got almost the lowest of low frequencies, the second lowest of low frequencies, why aren't we perfectly safe with microwave, cell phones, and everything else in the... Oh, you say there was another letter in this formula. That's right. This was not the Planck formula equals HF. This is the classical wave formula. And for a classical wave, the energy and the destructiveness depends on the amplitude. Now, whether or not electromagnetic waves are classical waves is an experiment that still remains to be performed when we bust out the $2,000 lab that Einstein got his Nobel Prize for and see what we can make of the photoelectric effect. But for the moment, we can map it with a sine, we can map it with a cosine. It looks like a duck, it quacks like a duck. If we're lucky, it's not a duck-billed platypus. We're going to assume that electromagnetic waves are classical waves and say the other problem is not the frequency, it's the exposure. Amplitude, we said, can be visualized as intensity, and the amplitude of an electromagnetic wave is the exposure overall. You do not want a cell phone tower in your backyard. That's where the not in my backyard movement, as short-sighted as it is, gets its name from a very fair point. We said 4.5 Roentgens of background radiation a year was no problem. That is the kind of exposure that evolution on this planet has left our immune systems able to cope with. Anything considerably more than that, it's not the frequency problem, it's the amplitude problem. Exposure builds up over years and massively, massively increases our cancer risk. Moral of the story, don't keep your cell phone in your pocket, especially you gents, if you want to be daddies someday. Keep this cell phone away from any of your biological cells that you want to pass on to the next generation, wherever you keep them. You have massive, massive amounts of electromagnetic waves in the radio wave frequency being transmitted, emitted, and received by this little thing. And members of your generation and my generation have spiking cancer rates through the roof by virtue of having too much exposure to too many electromagnetic waves. There's a nasty brand of breast cancer that's appearing in very young teenagers not much older than you and 20-somethings, right here, shall we say, with an almost 100% correlation for fine-strapping Southern women who keep their cell phone in their bra holster and now have a huge tumor where that holster used to be. Ladies, keep your cell phone in your backpack or your purse. Men, keep your cell phone in your satchel, your backpack, or your man purse. They make them in a variety of camo colors and navy, very professional looking. Take it wherever you go. You can have it in your pocket from time to time, but don't make a habit of it. Similarly, do not put your cell phone to bed right by your head for the 8 hours, wouldn't that be nice, that you're going to bed. Charge it across the room, better still, in another room. Where are we getting this difference? We'll see with waves, gravity, light, chemistry, and just about anything else that it spreads by an inverse square formula. A sphere has an area of 4 pi r squared, so double the radius, r squared goes up by 4. Move your cell phone twice as far away, you've cut the exposure not in half, but in quarters. Move your cell phone 10 times as far away, you've cut your exposure by a factor of 100. So much lower amplitude, less energy, not as destructive. What about those microwaves? Well, in the emergency room and in the medical trade, this is called RF burns. Don't go there. Don't get too much exposure to microwave radiation. You won't get cancer. Cancer is the problem you get with high-frequency radiation. Microwave radiation is not high frequency. You will get RF burns. What are RF burns? RF burns stands for radio frequency. Radio frequency burns mean your microwave is designed to cook things that are mostly water. You are mostly water. Seriously? Did this patient just cook himself in his own microwave? We're not billing for this. Don't cook yourself in your own microwave. Bark, 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 bark. Doesn't look good on your health insurance printout, so they call it RF burns instead. If you put yourself in your own microwave oven, you will be cooked just like the food in your microwave oven, and you will have only yourself to blame. Moral of the story, don't cook yourself in your own microwave. Close the thing we call a door and keep the microwaves in. That leads to the next question. Once you close the door, can the microwaves get out? The other thing for you to look up tonight, after you've finished looking up the inverse square law for the sheer intellectual pleasure of it, is how electric and magnetic fields deal with metal. Look at this photograph. You can tell the inside of this microwave is not plastic. It's very well painted metal. And if you ask somebody in the other class who has done electric fields, they will assure you that no electric field in the world can move straight through from the inside surface to the outside surface of a piece of metal. It's physically impossible. The door is also lined with metal. You close the door. Wait a minute, I can see through the door. Yeah, the door has little holes, just like these little holes. And if you check in your video notes, you will see that the wavelength of the common cooking microwave is 12.2 centimeters. And nothing 12.2 centimeters long can get through any of the holes in this little screen. Close the door, the latch latches. It latches perfectly. You have a solid 6-sided metal box, and none of the microwaves get out. They stay in the microwave oven. They cook your food. You're perfectly fine. Are you sure? Are you positive? Are you willing to bet your health and the ability to dance at your children's weddings on how good that door latch is? Why risk it? Back up by a factor of 5. You'll reduce your exposure by 25%. If just by chance there's a little tiny leak in the plastic latch of the door and a few microwaves get out to cook anything that's handy in your kitchen, you want it to be not you.